Good afternoon, everyone. I know Craig did a great job of sending out some really good information for all of us about severe weather and tornado safety, tips and recommendations. And I thought I would go ahead and share this little presentation I made and have delivered previously that just kind of talks about a little bit more of the science behind severe weather, why we have severe weather here in this part of the world, what we can tend to expect every spring and summer in Northeast Kansas, and really just to give a little bit more depth behind the forecasting and where to go to find really good information during a severe weather event. So again, kind of what I'm going to talk about is a little bit of the climatology, the science of severe weather. What are the ingredients that we need? How to be prepared before the storm, during a storm, and then after a storm. A lot of times we miss that part because really we honestly most of the time don't expect anything bad to happen. So we'll talk a little bit about personal preparedness, what that looks like. I'm going to share with you some of the resources that I use for forecasting and how to keep my family safe. And then I want to look at a case study of Greensburg because that really gives a good example of how even multiple days ahead of an event, the weather enterprise is working to try to keep people safe. So just from a sheer climatology standpoint, for Northeast Kansas, we can expect to see approximately 45 thunderstorms per year or days per year. So that means a day where we have some level of thunder and lightning. Obviously, year to year will change. Last year was a much more active year than what we're used to. Depending on the years where we're in drought, we obviously have much fewer, but give or take about 45 thunderstorm days per year. Most of those are garden variety. They're not a problem. They're not significant. And we're mostly used to it in this part of the world. We talk severe weather. There are criteria for what makes a severe thunderstorm severe. Basically, that's 1 inch diameter hail or larger and roughly 60-mile-per-hour winds or higher. This is a map showing, on average, the number of severe thunderstorm watches one can expect per year. For Riley County, we're right about 16. You can see areas kind of just south of us from the Flint Hills down through south central Kansas into central, north central, northwest, into western Oklahoma are a little bit higher than we are. Also areas really farther out northwest as you get into kind of the lee of the Rockies in the summertime. Sometimes they will see more active weather, but for Riley County, we're really kind of right on the northern tier of what's generally considered the most active severe weather region in the United States. For tornadoes, average number of tornadoes by state per year. Kansas, we average about 96, which is second only behind Texas. Between Nebraska, Kansas, Oklahoma, Texas, Iowa, Missouri, that's really the bulk of the springtime severe weather. Obviously, you get down into the deep south of Mississippi, Alabama, Georgia, Tennessee. They have, and especially recently, have had some very large outbreaks. Theirs tend to happen earlier in the year. Ours tend to happen more April, May, June timeframe. But again, this is something that we're relatively used to in this part of the world. When we talk about average number of tornadoes per year, obviously, again, there's a wide range of that based on what the overall weather pattern is like. But in general, for our region, for our area, and what I've done is I've created that little box there that's about 50 square miles by 50 square miles, or I'm sorry, about 50 miles by 50 miles, meaning that in a 10,000 square mile area, we can expect about 5 tornadoes per year. So that doesn't mean 5 in Manhattan, obviously, or even in Raleigh County, but in the area around us, about 5 per year is not unusual. Again, you get into far southern Kansas, central Oklahoma, and northern Texas, that number bumps up a fair amount. Tornado watches per year, again, we said 16 severe thunderstorm watches, about 8 tornado watches on average here in Raleigh County. Again, you get in other parts of the United States, and that varies a little bit, but again, still kind of the central part of the United States being the primary area where we see that. Once we get into the deep south, the other thing that skews those numbers a little bit higher is that with hurricanes in the fall, a lot of times there will be subsequent tornado watches in those regions as well. So we talk about odds increasing over the next coming weeks. So I pulled some tornado probabilities for March, April, May, and June. Or I'm sorry, March, April, and May. You can look at in March right here in this area, our tornado probabilities are pretty low. You jump forward in time about 4 weeks to mid-April, probabilities have started to go up. Oklahoma is kind of the bullseye there. The first week in May, you're starting to see that area expand even further north. And then we go into mid to late May, again, even more expansion to the north and to the west. And so really our peak tornado season in northern Kansas probably is May, June timeframe. But really any time of the year we can get that kind of severe weather and deal with those kind of issues. Let's talk about a little bit about the science of severe weather, what causes severe thunderstorms. Really 4 key ingredients that we need to all be in place to get severe thunderstorms and tornadoes. The amounts of each one of these 4 can change, and based on the amount, the type of severe weather can be a little bit different. But it's really a mixture of all 4 of these that combine and work together to make our severe weather and tornadoes. So the first of these is shear, and wind shear comes in 2 forms. There's directional shear and there's speed shear. And basically what that means is this, and what you have to remember is this. What's happening at the surface is not necessarily what's happening at different heights throughout the atmosphere. And that's really key to this whole understanding of severe weather and thunderstorms. 2 things can be happening with height. And so this side over here that talks about directional shear, with height, the winds may be turning. There may be winds at the surface coming out of the south or southeast or east. That's most common in this part of the world for severe weather, is a strong southeast easterly wind. You go up a few thousand feet and now the wind's out of the south. You go up a few more thousand feet, the wind's out of the southwest. A few more thousand feet, the wind's out of the south, or I'm sorry, out of the west. And so that directional shear creates turning within the atmosphere. And so that is what thunderstorms then can tap into as they form and as they move across the region to begin to rotate. The other type of shear that is very common is what we call speed shear. And speed shear is a different wind speed with height. And so at the surface, the wind is going a certain amount, miles per hour as we go up. Generally speaking, on a good severe weather day, that amount will increase. And that's where we really start talking about the jet stream and upper level winds and why that's very important. What that does then, and you can see it again with this picture of this thunderstorm anvil, is that it causes the thunderstorm to tilt. And so as air comes up, as air is moving up through that thunderstorm, if there's no speed shear, air will come up and then come right back down, and that downdraft is what will eventually kill the thunderstorm. Speed shear causes the storm to tilt, and so as air comes up, it then comes back down at a different location, and that allows that storm to live longer and not be cut off from colder or cooler air. What wind shear looks like on radar, probably you've seen this kind of radar display before, but on the left here is a Doppler radar display of reflectivity. So this is rain, hail, those kind of things. And then this is velocity. So this is looking at the movement of those particles. And so you see air coming into the storm from the southeast, wrapping around, and then this is the actual tornado itself right here. On the velocity mode, what you see is the green and the red. The green is air moving toward the radar. Red is air moving away from the radar side. And so where those two come together very closely like that, it's called a couplet, and that's where you see the actual tornado itself, or at the very least a mesocyclone, the rotation within the thunderstorm. Ingredient number 2 is lift. There has to be something to get air moving upwards. All thunderstorms, all rain is based on this idea that air has to rise. And we know the warm air is more buoyant. Warm air rises more rapidly than cold air. But there has to be some kind of a mechanism to get the air to start to rise. Air likes to sit still, just like we all do. And so there has to be something to get the air moving. What that can look like a lot of times in this part of the world is what we call fronts. So a warm front, a cold front, a dry line, something that's getting the air to move, to mix, and to start going up, to begin lifting is very important. Third ingredient is instability. Instability is kind of like the juiciness of the air, or how much energy is potentially there. It's measured in a thing called CAPE. It's convective available potential energy. And again, it's kind of this measure of if you can get that air to start to rise, how fast and how violently will it rise? The higher the CAPE number, the higher the level, the more rapidly it will rise, and the more explosive the thunderstorm growth will be, the more explosive or the longer lasting that storm is likely to be. Generally, with any kind of severe weather, you need CAPE of at least 500. So that's some level of instability. For significant severe weather, where we're talking, baseball, golf ball size hail, big tornadoes, you want CAPE above 2,000 really. And there are times in the late spring, early summer where it's June, it's really hot, it's really muggy, it's really humid. You can get CAPE values above 5,000, and that's where again CAPE most directly associates with large hail, honestly, because again it's that energy of air rising really rapidly, and so when you see those really high CAPE numbers, that's when you really start thinking about really, really big hail. Moisture is the last ingredient. This one's pretty self-evident, but we have to have moisture to get thunderstorms moving. Moist air, like we said, warm air is buoyant, moist air is buoyant. The number that you want to look at is dew points. If you watch the weather on TV or if you have it on your phone, people a lot of times will look at humidity. When we're talking severe weather, humidity is pointless. It's really about dew points. And so you want dew points really ideally higher than 60 degrees to have significant severe weather. Mid 50s, you can still have storms. In fact, today we may have some severe weather. Our dew points are in the mid to upper 50s, but really about 60 is what you want to see. Part of the reason for that is that a higher dew point means that the boundary layer will be lower, and what that means is that the base of the storm and the surface of the earth, that distance changes. You go out to western Kansas, eastern Colorado, a lot of times there's a huge difference between that because the surface is pretty dry. That's where you get those really pretty but really kind of ropey looking tornadoes that are not very big around. The further east you go, central Oklahoma, central eastern Kansas, you get a lot more lower cloud bases. That's where you can a lot of times get more like the wedge tornadoes. Happens at night a lot as well. So you want that moisture. So again, shear, lift, instability, moisture are the 4 key ingredients for severe weather. So again, this is basically what a schematic of a supercell thunderstorm. And you've got the air coming into it, the updraft. As air goes up, it rotates. Because of the wind shear, the updraft is tilted. It's not straight up and down. Because of that, the outflow and the downdrafts come down here. That's where you get the rain, you get the hail. On the backside, though, this is where air is flowing into the storm. You get some level of rear flank downdraft, and when all that kind of works together perfectly, and it doesn't happen very often, but when it works together perfectly, that's when you get a tornado to form. So let's talk a little bit before, during, and after a storm. So first of all, before the storm, you need to know your forecast. Again, we all have cell phones, we all have weather apps. During severe weather, your weather app may not be that useful for you. You really need to get good weather forecasting. The National Weather Service all across the nation, there we have several offices that cover different parts of Kansas. We're in the Topeka office, area of responsibility here in Manhattan. They do a good job, and they're the ones that give out daily forecasts. They're also the ones that actually issue the warnings when storms are going on. The other is the Storm Prediction Center, and that's kind of a branch of the National Weather Service, but they're based in Norman, Oklahoma. They do the actual severe weather forecasting the day of and multiple days in advance. They're also the ones that actually issue the watches. And I'll show you what their website and what their terminology looks like in just a second. But first is really know your forecast. Second is know your hazards. What kind of severe weather can be expected? Are we talking about a tornado outbreak? Are we talking about just some garden variety storms? Is it just maybe some small hail, something like that? Or is it something that really we need to pay attention to? And then third is know your plan. Don't wait until storms are occurring or are about to occur to think about where you'll go. And it's one thing to know where you're going to go at work. It's another thing to know where you're going to go when you're at home. But think about the in between. And if you're at Walmart, if you're at Hy-Vee, if you're at a baseball game, if you're at a football game, whatever that may look like, think about those kind of places. Depending on the forecast, it may be best to change your plans on certain days like that. But above all, make sure you have a way to receive information. Again, because we all have smartphones, that's a great way to receive weather information. But knowing if you're out on the lake or if you're out doing something outdoors, especially, know how you're going to get that weather information. I mentioned the forecast offices for the National Weather Service. Again, we're in the Topeka office. Different parts of the state are covered by different offices: Hastings, Goodland, Wichita, Springfield, Pleasant Hill. The websites are very easy. It's just weather.gov/whatever office you're in. So weather.gov/Topeka is our local National Weather Service forecast office website. Storm Prediction Center, like I said, they issue daily convective outlooks. They also issue mesoscale discussions, and really what this is usually a technical discussion before a watch is issued of kind of what they're expecting, and then they do issue those watches. The daily convective outlooks are really the most important and the most helpful thing they issue, because that's going to tell you a lot of what are they thinking. What do we need to be aware of? They have different levels, different colors. I'm going to jump out of sequence and come back to that. It goes from marginal, slight, enhanced, moderate, and high. It's important to note that storms don't know what color they're in. Obviously, these are forecast tools, but at the same time, if you see an enhanced risk, we will in Northeast Kansas be in a slight risk of severe weather, a few dozen times a year. That's not unusual. If you see an enhanced risk, that's, hey, we need to be a little bit more aware of this. The moderate risk doesn't happen very often, maybe once or twice per year. And a high risk may not happen in a full year for this part of the world. It's even more rare. When you see the moderate, when you see the high, those are days that you really, really need to pay attention. Widespread, strong, severe weather, strong tornadoes are likely on those kind of days. Again, something bad can happen on a slight risk day. That's not to say don't pay attention to that, but the colors and the numbers are important to understand. Let's go back to the forecasting. So again, this was a snapshot of a day back in 2017 that I grabbed. You can see the different areas. There was a high risk day for South Central Kansas, Northwest Oklahoma. Around that, you see the moderate, the enhanced, slide, the marginal. They also do forecasting for tornadoes, and they do it by probability. And so 30% chance of a tornado within this pink area here, hail 45%, damaging winds 30%. And so that just gives you an idea of kind of what their forecasting looks like on a day-by-day basis. Again, it's a great planning tool as you're looking forward. During the storm, so once we have the storm ongoing, you would hope everyone knows this, but it's amazing how you have to remind people the difference between a watch and a warning. A watch means conditions are favorable for severe weather, whether it's tornado watch, severe thunderstorm watch, flash flood watch, whatever that may be. It means conditions are favorable. It's issued for a large geographic area, and it's usually hours in advance. It means basically stay tuned. Be aware that things are likely to become more active than they are right now. When a warning is issued, that means that severe weather is imminent. It's either ongoing or it's expected to develop in the next few minutes. These are issued minutes in advance. Usually they're issued for 30 or 45-minute increments, time frames. And it means take action, do something. There's the joke about a tornado warning means go outside and look on your porch, do what you want. But the point is, take warnings seriously. And they're issued, it used to be the warnings were issued just by county. A few years ago, they changed that to what they call a polygon warning system. And so you see the picture here, if there's a tornado warning for this storm right in this area right here, in the old days, you would have 1, 2, 3, 4, 5 counties. It would all be in one tornado warning. It's a little overkill because if you're down here, there's no risk for you at all. What they've done then is they have these polygons that they draw. And so the idea is that within this area, that's who needs to be taking shelter. So pay attention to the polygon when there's a warning that's issued. How do you get your warning? Well, the best advice is have multiple ways to do that. More than one, because one may not serve you well. Things can fail. So having a weather radio, especially at night for nighttime tornadoes, is very important. We saw a few weeks ago in Nashville when they had their very large tornado that went through parts of Tennessee. A lot of people were awoken by their weather radio that saved lives. There are notification systems out there by county emergency management. I know Raleigh County has one that you can sign up for. There's a plethora of cell phone apps. Just make sure it's a legitimate one, a good one. Local media outlets are still a favorite, whether that's AM, FM radio, TV. Outdoor warning sirens, key point, that's for outdoors. Warning sirens are not meant to wake you up in your home at night with your air conditioner running, a storm going on, it won't work. So sirens are great for outdoors. They're not great for waking you up inside, and they don't tell you anything. They can convey no information about the storm. It's just to give you a heads up. And then finally, social media can be helpful. The challenge with social media is, again, it's not always in the right order. We don't always get those posts in the right time frame. So keep that in mind. A couple of quick safety things on actual hazards. Lightning, obviously, get inside a sturdy building, a structure, a vehicle, avoid trees, avoid open metal structures, water, open areas. Again, inside's your best bet. And understand that lightning can happen miles away from an actual storm. So if you can hear thunder, you're close enough to be impacted by lightning, is the basic rule of thumb. A severe thunderstorm, again, sturdy structure, preferably away from windows. There's a big difference between a severe thunderstorm that is, quarter-size hail and 60-mile-an-hour winds, and storms that I've seen where it's baseball-size hail and 100-mile-per-hour winds. You don't want to be in a flimsy structure in that kind of a storm. So take this seriously and continue to monitor, because very rarely does a storm go from nothing to a tornado warning. There's almost always a progression between storm form, storm is severe, storm becomes tornado warned. During the storm, obviously this is an outdated slide. I apologize. I thought that I changed this, but I did not. It still says KDA building because that's where I was at last year. Forget that. Use Craig's information that he sent out for at work, for the BRI, where our safe spots are there. At home, again, you want to be the lowest level as possible. Put as many walls between you and the outside as possible, preferably no windows. Protect your head and your eyes. Put on a bike helmet if you have one. Put on safety goggles if you have one. Put on a heavy coat. Grab a Carhartt, put something like that on. And then store your kit. If you have an emergency kit, put it where you will take your shelter. So like for us, we have a basement. We have a little room underneath our stairs going into our basement. That's where we keep our family's storm shelter kit. It has bike helmets in it. It has goggles in it. We know everything is there if we need it. The other thing that I didn't put on this, but I would highly recommend, is put on shoes. Especially if it's the middle of the night, put on strong, sturdy shoes, because if you actually have damage, it's going to be broken glass, it's going to be nails, things like that. You want to have on shoes. Do not wait for visual confirmation to take shelter. Trust the scientists, trust the meteorologist, trust them that you need to be in the shelter if there's a tornado warning issue. If you're in a vehicle, they're all bad options. I get that question a lot of, well, what should I do if I'm in a vehicle? It used to be, go get in a ditch. Nobody wants to do that. I don't want to do that. Nobody wants to do that. Basically, your best bet is find a substantial shelter to go into if you can. Find a place, get off the road, get in a strong, sturdy building. If you can't, maybe a ditch is your best bet. The one thing I would say, though, is watch out for flash flooding, because there have been people that have died because of that. They've been taking shelter in a ditch. They died from flash flooding. Do not stop or take shelter under a highway overpass. Two problems with that. Number one, it can actually make the winds move faster. The other is that it blocks the highway. You're going to block other people who don't want that option, that want to do something else, or emergency vehicles, fire, police, things like that. Do not stop under an overpass. By the way, if you're in a city or if you're anywhere and it's hailing, don't stop under an overpass then either. That's just being selfish. You should have made better choices. Don't be in that situation. And then finally, you can drive away from a storm, but only if you know the storm's movement and you have a clear escape path. Don't leave a shelter to try to outrun a storm. But if you're on the road, if you can see the storm, if you know what direction it's going, you know what direction you're going, you can drive away from it. Key is they're all bad options. Best option is don't be on the road during a tornado. Flash floods, avoid creeks, flood-prone areas. Never drive into flooded roadways. You do not know what's there and if the road is still there or not. And then again, after the storm, think about secondary hazards. What's going to happen after the storm is over? Are we going to have down power lines, flooded roadways? There's probably going to be debris, again, nails, glass, things like that. There may be gas leaks, there may be fires. A lot of times in this part of the world, we get storms that come in waves. And so we may have one round and then another round coming after it. Know how you're going to continue to track that and track other weather. Know how you're going to have a plan to get in contact with family members as well, to notify them of your condition and your status. So personal preparedness, have a plan, make a kit, stay informed. 3 keys that we always talk about in emergency management. For some additional resources, these are just based on my personal opinions. This is what I use. Cell phone radar app, radar scope. On my cell phone, I can do basically anything that a TV guy can do. It's as good of a tool as there is out there in the world right now. For a forecast app, the National Weather Service doesn't actually have an app, but they have a widget that you can install that gives you mobile weather based on their forecasting. If you like model data, if you really like forecasting, there's the Pivotal weather page. Satellite imagery, the College of DuPage has a really great website for not live, but as close to live as possible satellite imagery. Surface observations, Kansas Mesonet, it's mesonet.chaos.gov. Situational awareness, again, I use TweetDeck, so I can follow a lot of different people at a time. Main thing is if you have questions about any of these or would like direction, shoot me an email and I'd be happy to walk you through this in a little bit greater detail. So real quick, I know I'm almost out of time, but real quick, talk a little bit about Greensburg. And again, this is kind of a semi-case study, but I just want to talk about this through this really quick to show how this all works together. So multiple days in advance of the Greensburg event, the Storm Prediction Center was already highlighting that area as a potential region for severe weather. So you see up here the day 5 to 7 outlook. They're already saying, hey, Western Oklahoma, Western Kansas, Central Texas. Day 4 to 5, they refine it a little bit more. 3 days out, we have a slight risk area developed for Western Kansas, Western Nebraska. And again, remember, like I said, slight risk doesn't sound like a lot. You still got a tornado like Greensburg. Day 2, it's a little bit bigger area, but again, they're constantly refining this forecast. Things change, the forecast changes. But I just wanted you to see that for 4 days, 5 days out, they're already looking at the area where they're thinking there's going to be severe weather. Day of the event. And so I will mention this is a little bit different because when this was going on in 2007, they did not have the enhanced risk. So that's why it goes straight from slide to moderate. They didn't have the enhanced risk at the time. But you see now a moderate risk area. And so this was the 11:50 a.m. Update, and they now have parts of western and southern Kansas updated into a moderate risk, and it says, the NWS's Storm Prediction Center is forecasting the development of a few strong tornadoes over parts of the Central Plains this afternoon and tonight. Pretty straightforward. So at 3 o'clock, we get a mesoscale discussion, and so this is preceding a tornado watch, but they put this out here and showing, here's the surface. We have a front, we have a low pressure, we have a dry line. This is the area that they're thinking the storms will develop. And again, if you read the text, and this gets really technical, these aren't written for everyday people to read, but I just want you to see that there are things in this that are applicable and that there are people that are seeing this or reading this that then are trying to convey messaging to everyday people that maybe aren't scientists. But it says, the key phrase there, that last one, in addition to the risk of very large hail, isolated strong tornadoes are possible, particularly as low-level jet strengthens near and shortly after O4Z. And so that O4Z, everything is in Zulu time. So that's basically after, I'll do math in my head for a second. After 8 o'clock. 9 o'clock. 8 o'clock, somewhere there, after dark. At 6:15, we have our first tornado watch issued. So again, you see the progression. We had 11, almost noon, 3 o'clock, 6 o'clock, tornado watch issued. We have one storm, one going up here in Ellis County in Oklahoma. Discussion, widely scattered storm supercells are possible in very unstable air mass along slowly retreating dry line this evening. Strengthening wind field associated with approaching Four Corners trough may enhance tornado potential after dark. So again, they're saying storms are forming. After dark is when we're really expecting a significant tornado event to occur. This is a little bit of the sounding of what this looked like. You can see this is showing wind shear. It's showing instability. All those things are going on. Here's a surface map. Different levels of the atmosphere showing what the wind speed and winds of the surface. a little higher up, a little higher up, a little higher up, just showing wind shear, showing that there was both speed shear and directional shear present in the atmosphere over southwest Kansas at the time that they are forecasting these tornadoes to occur. So at 9:41, so again, let's go back. So we had tornado watch issued at 6:15. At 9:41, we have a tornado emergency issued by the National Weather Service in Dodge City for Kiowa County, for the city of Greensburg. This is what the radar image looked like. Again, you see the classic hook echo shape. Air is coming into the storm here, rotating around. That's the actual tornado. The velocity mode, here's Greensburg. Air moving toward, air moving away. There's your couplet. There's the tornado on radar. And like most storms, like most significant tornado events, this storm produced multiple tornadoes. It just happened that Greensburg, the town, was in a very negative spot. They got hit by one of the larger tornadoes, but this one storm produced at least 21 tornadoes just within Kansas, and that doesn't even count in Oklahoma. There was another storm at the same time, or further south in Oklahoma, that produced a huge tornado. It just didn't hit anything. So you had at least 2 thunderstorms ongoing at the same time, producing multiple large tornadoes. And so being aware of that and knowing here's what's happening, here's what's going on is so very important. So obviously can't take questions because I'm recording this, but I would be happy to answer any questions that you might have virtually. Other than that, thank you very much. Enjoy this if you want to look at it, and hopefully we will get to see each other again one of these days to be back in the office. So thank you.